Hello, this is Physics 112, lecture number 24. We are still on chapter 21 and I'm going to do resistors in parallel. So I'm just going to use only two resistors. And so here resistor R1 and R2 are in parallel. And on each side it is connected at point A and point B. It is connected to the terminals of a battery, and the battery source potential given by this battery is V. Alright, now there'll be a current flowing. So this is a longer line, that is a positive node, shorter line, negative node, and the current will be flowing from negative to positive, and it'll go like this, right? So when it goes like this, the current, let's call it I, that current, when it hits this junction, it has to split because there are two ways to go. So the current, amount of current that goes up is, let's call it I1, then amount of current that goes is current I2. Okay? Now what we want to do is we want to find the total resistance or equivalent resistance of these two parallel resistors. By the way, once the current go in with I1 and then current I2, they will join here at point B, and then it will become total current I again. Alright, so keep in mind, just like water flowing in pipes. So 10 gallons per second flowing here, then you divide it into two ways, 3 gallons per second and 7 gallons per second, but nevertheless the sum is still 10 gallons per second. Alright, okay, so now what do you mean by an equivalent resistor? Is instead of having these two parallel resistors, let's suppose I have only one, which will have the same effect as having these two guys in parallel. So this is, I call it R total or R parallel. I'll write RP so that you'll remember the voltage here is V, the current is still I. Right? So instead of these two now, I have only this. So that's what I call the equivalent resistance or equivalent resistor. And I want to find this RP, which will be equivalent to these two in parallel. So what I have to know is that the current I1 and I2, they add up to total current I, right? Because I split into I1 and I2. So I know that I is equal to I1 plus I2. Now, between these 2 points A and B, the voltage drop for the upper branch through R1 or the voltage drop through the resistor R2, the lower branch, will be the same. Still, it will be VAB, the voltage drop from A to B, which is the same as this V. So VAB or VAB is just V. But from Ohm's law, we know that V is equal to IR. But for the upper branch, V is I1 R1. And for the lower branch, V is equal to I2 and R2. Right? The current is I2, resistance is R2. So now I want to find I1 and I2 in order to substitute here. So I1 is equal to V by R1 and I2 is equal to V by R2. So far so good. Now for the equivalent resistor, this one, then still Ohm's law apply. So V is still IR. So for the equivalent resistor on this circuit, V is equal to IRP. So then I is equal to V by RP. So now I can substitute it here. So I is equal to V by RP. I1 is V by R1. And I2 is V by R2. So you see the voltage drop from A to B is the same for all these two resistors, so the V is the same. And similarly for this equivalent resistor, same V, so these V's cancel out. I get 1 by RP is equal to 1 by R1 plus 1 by R2. So if you have more than 2 resistors, then I'll just write 1 by R1 plus 1 by R2 plus until all the resistors are gone, right? So if you have 5, then I'll have to write 1 by R1 plus 1 by R2 plus so on until you get to 1 by R5, right? So that's the formula for equivalent resistance for resistors in parallel. Now I'm going to do an example. This example is example 21.2. So in this example, what we want is the following. First of all, a circuit is given. So I'm going to draw the circuit, and if you should look at the figure, it's figure 21.4. So you have a resistor here, another resistor here, and another resistor here. Doesn't matter whether 3 or 4 or 5 or 2, it's all the same procedure, right? And the voltage is V here. And so the voltage drop from here to here will be V, from here to here will be V, from here to here will be also V. This is R1, R2, R3. And V is given as 12 volt. They like 12 volt, don't they? And then R1 is equal to 1 ohms. R2 is equal to 6 ohms. R3 is equal to 13 ohms. They give some crazy numbers like 13, which is a prime number, so it's hard to divide, right? Now, for A, I'm not going to read the whole problem, but what they want is, first of all, they want you to find the equivalent resistance for these 3. So you want to find RP. B, you want to find the total current, that is the current going through here, right? So you want to find the current I. So total current. And then for C, then you want to know the current in each branch. So let's call it I1, let's call it I2, let's call it I3. So you can imagine current I coming here, and then I1, amount I1 split into this branch, and the rest keep on going, and then I2 splits into this branch, keep on going with I3. Then here I3 coming down, and I2 and I3 combined, and then finally combined with I1, and then it'll become I again, right? So that's how you should see it. So C is you want to find I1 plus I2 and I3. Of course, when you add these 3 up, it should be equivalent to I. It should be equal to I. And part D is you want to find the power dissipated in each resistor. So power dissipated in each resistor, P1, P2, and P3. That's what we want to find, okay? So we'll find that P is equal to IV or I square R. So you get, or V square by R, you can use any of those formulas. And then E is, you want to find the power dissipated in the whole thing is equal to, the total power dissipation is equal to P1 plus P2 plus P3. That's what you want to show. All right. Okay. So let's do that. So let me go to the next page. So in order to find the equivalent resistor, we already know the formula. And the formula is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, right? So now R1, R2, R3, so let me see, this is 1 by 1 ohms plus 1 by 6 ohms plus 1 by 13 ohms. So if I find the common denominator, I can find that 13 times 6, and you get 78. 1 goes into 78 times, plus 6 go into 78 13 times, because I just multiply these two, so it's easy to divide. 13 goes into 78 6 times, right? So 1 by Rp is equal to 78 plus 13 plus 6, and then you divide by 78, and you will get, let me do it for you. So that's 78 plus 13 plus 6, you get 97, and then you divide it by 78, so you get 1.2435. So 1.24358. So let me call it 36. Okay, so I have to invert that to get Rp. So Rp is equal to just, I can do the inverse, but I'll let it be just to the 1 divided by 1.2436 is 0.8041. So 0.8041, the units is in ohms. All right, so I get number one answer, Rp is this much. That's the equivalent resistance. Okay, now for part B, I want to find the total resistance in the circuit. Total current in the circuit. So remember, if you recall, let me show it again. This is the circuit, that this and this parallel. So equivalent resistor means that I replace those three with one resistor, right? And that's what Rp is, equivalent resistor. Now the current will be flowing, here is I, so that's the total current flowing in the circuit. Although here in this figure they branch out. In this figure, because you draw only one equivalent resistance, then they don't have to split, right? And I want to find this I, right? So the part B is to find the total current I, mean this I, right? So if I do that, then V is equal to IR, right? V is equal to IR, so it's easy. IRP, and I know I want to find I, so I is equal to V by RP. If you notice, I don't substitute numbers first, I do the algebra first, so it's so that it'll be harder for you to make mistakes. So I is equal to V by R. V is 12 volt, and R we just found 0.8041 ohms, and I find that I is equal to 14.92 amperes. All right, so I is 14.92 amperes. So that's part B. Now let's go to C. So part C, I need to find the current in each branch. Let me go to that figure again. So I want to go find current in here, and here. But we know that V is equal to IR. V is the same for all three branches. From here to here, the voltage drop is V. From here to here, it's also V. From here to here, it's also V. So I just have to use V is equal to I1 R1, or V is equal to I2 R2, or V is equal to I3 R3. Okay, so if I do that, let me do it. V is equal to I1 R1, so I1 is equal to V by R1. I can find that. V is 12 volts, and R is 1 ohms, so the answer is 12 amperes. That's I1. Similarly, I2 is equal to V by R2, so I find 12 by 2, 12 volt by 2 ohms, so the answer is 2 amperes. And I3 is equal to V by R3, which is equal to 12 volt by 13 ohms, and that is a little odd number, that is 0.92 amperes. Okay, so I get all the current, and of course if I add them up, let's check. I1 plus I2 plus I3, if I add them up, 12 plus 2 plus 0.92, that is 14.92 amperes. You see, so this is the same as this number, right? So the total current is the summation of all three currents. All right, so that's part C. And for part D, we want to do the power dissipation in each branch or each resistor. So the formula is simple, right? The formula is P is equal to IV, and we also know that P is equal to I square R, and is equal to V square by R. Okay, how do I get these? Let me explain again. I have done this so many times, but let me do it again. V is equal to IR, so if I put V is equal to IR, then I times I is I square times R, so I get this, V, P is equal to I square R. Similarly, instead of V substituting for V, I can substitute for I, because V is equal to IR, so I is equal to V by R. So if I substitute I is equal to V by R here, then I get V square by R. Okay, so that's how we get these formulas. So I'm just going to use P1 is equal to V square by R1, and V is the same for all three, so all I have to worry is R1, and V square is 12 volt squared by 1 ohm, so 12 square is 144, so the answer is 144 watts. P2 is V squared by R2, which is equal to 12 volt squared by 6 ohms. So the answer is 24 watts. And P3 is equal to V squared by R3, which is equal to 12 volts squared by 13 ohms. And the answer is 11.1 watts. Now for part E, I want to find P again, but from here, right? So this is V, so I want to find power from this circuit, and then so if I do that, what do I get? P is equal to IV, and I is the total current. So the total current, we know the total current is 14.9 amperes. That is from here, right? Or from here, from part B, the total current, or I add up I1, I do I3, I get the total current. V is 12 volts. So 12 times 14.9, let's see. 12 times 14.9, and we get 178.8. 178.8. Okay, or 179, right, watts. And I add these up, and if I add P1 plus P2 plus P3, it'll be 144 plus 24 plus 11.1. So what do I get? I get 140, 168, 170, 179. 179, right? Watts. Okay, so this is also actually 179 watts. So both of them are the same. All right. Okay. So, and the reason we don't get exactly 179 is because there are a lot of decimal places that we left out. All right. Okay. All right. So you can look in the book example, but anyways, that's how you go through that.